All right, let's begin with the class. Objective is that we are going to cover the first category of differentiation. I have divided differentiation in three different categories and compiled the past papers also in three different categories. The first one is general category, in which there are a lot of general things like the differentiation of exponential, logarithmic, trigonometric functions, product rule, quotient rule, uh, right? Mostly these things are going to be covered. Apart from that, I'm also going to teach a method for finding the nature of the turning point, which we didn't study in AS. And then comes second category of differentiation, which is parametric, and the third is implicit. So I've divided it into three categories. The past papers are also compiled differently. So first, we are going to focus on the general category, after which, inshallah, uh, for some time, we are going to focus on this category, focusing on the past papers of this category, and then we'll move forward, inshallah. So let's begin. The first thing that we have to cover is differentiation of exponential, logarithmic, and trigonometric functions. So when we see this d upon dx written, this means differentiate with respect to x. So this means if d upon dx of e f x is written, this means we are differentiating e power fx with respect to x. How do we differentiate e power fx with respect to x? So differentiation of e power fx is equals to e power fx multiplied by f prime x. What we have to do is, whatever the exponential function is, if we are going to differentiate it, we will copy that as it is, and the differentiation of the power will be multiplied. First, we are going to copy the exponential function as it is, and then the differentiation of the power will be multiplied. जब भी exponential function की differentiation करनी होगी, तो उसकी differentiation में उस exponential function को as it is copy करेंगे, और उसके बाद जो उसकी power होगी, उसकी differentiation को multiply करना पड़ेगा. तो अगर हम आसान example देख लें, e power 2x. So e power 2x is e power 2x and multiplied by the differentiation of 2x, which is 2. So e power 2x multiplied by 2, the answer is 2e power 2x. Then comes the second function, ln fx. What is the differentiation of ln fx? The differentiation of ln fx is 1 upon fx multiplied by f prime x, or we say f prime x upon fx. What does this mean? Whenever we are differentiating the ln function, then the function comes in the denominator and the differentiation of the function comes in the numerator. जब भी ln of a function की differentiation करनी होगी, function denominator में आएगा और उस function की differentiation numerator में आएगी. Let's check out an example. ln 2x. So this 2x will come in the denominator and the differentiation of 2x will come in the numerator. So the differentiation of 2x is 2. So we are going to cancel 2 and 2 and we are going to be left with 1 upon x. The differentiation of ln 2x is 1 upon x after being simplified. Then third, sine of an angle. This fx is definitely the angle, right? Because sine is always applied on a certain angle. So sine of a function, sine being applied on an angle, which itself is a function. The differentiation of sine angle is basically cos angle multiplied by differentiation of angle. जब भी sine of an angle की differentiation करनी होगी, तो sine of an angle की differentiation होगी cos of an angle, and then at the end we are going to differentiate the angle and we are going to multiply it. Similarly, cos of an angle, if you check out an example, then sine 2x, the differentiation is cos 2x and then multiplied by 2 because the differentiation of the angle is 2. So it becomes 2 cos 2x. Then if you are going to differentiate cos of an angle, then the differentiation of cos angle is negative sine angle. Sine angle differentiated gets converted to cos angle. Cos angle gets converted to negative sine angle. So it's the differences of sine, right? Cos, sine gets converted to positive cos. Sine gets, after differentiation, gets converted to positive cos. And the cos gets converted to negative sine. And the differentiation of the angle will be multiplied. So if it's cos 2x, then it's going to be negative sine 2x multiplied by 2. So it becomes minus 2 sine 2x. Then tan of an angle when differentiated becomes sec square angle. And then the differentiation of the angle will be multiplied. So tan angle is equals to sec square angle multiplied by differentiation of the angle. So tan fx is equals to sec square fx multiplied by f prime x. So if you're going to check out an example, then tan 2x is equals to sec square 2x multiplied by 2, which becomes 2 sec square 2x. तो एक्सपोनेंशियल की डिफरेंशिएशन एज इट इज कॉपी होती है, पावर की डिफरेंशिएशन मल्टीप्लाई, एल इन एफ एक्स में फंक्शन डिनोमिनेटर में आ जाता है डिफरेंशिएट होकर, उसकी डिफरेंशिएशन फंक्शन की डिफरेंशिएशन न्यूमरेटर में आ जाती है, साइन एंगल कॉस एंगल में तब्दील हो जाता है, एंगल की डिफरेंशिएशन मल्टीप्लाई करते हैं, कॉस एंगल नेगेटिव साइन एंगल में कन्वर्ट होता है, एंगल की डिफरेंशिएशन मल्टीप्लाई करते हैं, टैन एंगल कन्वर्ट होता है सेक स्क्वायर एंगल में, एंगल की डिफरेंशिएशन को मल्टीप्लाई करते हैं। ये आपके सामने मैंने चंद एग्जांपल्स भी पेश किए और आपको ये मैंने पांचों रूल समझाए। I have explained all these 5 rules of differentiation. Are we all on the same page? Have we been able to understand this? Please confirm. All right, great. Third one, yes, definitely. Third one is sine of an angle when differentiated gets converted to cos of an angle. Sine 2x gets converted to cos 2x, and then the differentiation of 2x will be multiplied. So sine 2x is equals to cos 2x multiplied by 2, which becomes 2 cos 2x. Sine angle की differentiation जवेरिया cos angle होती है, cos एंगल की साइन एंगल माइनस साइन एंगल होती है, और tan एंगल की सेक स्क्वायर एंगल होती है। और जो एंगल की डिफरेंशिएशन है, क्योंकि एंगल इटसेल्फ इज अ फंक्शन, द डिफरेंशिएशन ऑफ दैट फंक्शन विल बी मल्टीप्लाइड एज वेल। Yes, is it clear now? Yes, Javeria.
So do we have to know the working we have done with the pen?
डेफिनेटली बिल्कुल सही है, करनी पड़ेगी। दीज एग्जाम्पल्स आर नॉट एसेंशियल, ये वैसे स्क्रीनशॉट लिख लें, अच्छी बात है, लेकिन ये मैंने ये 5 एग्जाम्पल्स भी नीचे ऐसे ही हैं, सेम टू सेम, तो ये वाले कॉपी कर लें वो काफी है। और ऐसे ही समझाने के लिए साथ साथ था, e power 2x square minus 3x as it is copy, and then the differentiation of the angle will be multiplied. And same for ln fx, the function comes in the denominator, and the differentiation comes in the numerator. Sine angle is cos angle, and the differentiation of angle will be multiplied. Cos angle negative sine angle, differentiation of angle will be multiplied. Tan angle sec square angle, differentiation of angle will be multiplied. Copy these 5 examples, you'll be clear with everything, right? Once you're done, just write done in the chat box. We are going to move forward. I guess you people have forgotten to write done. I told you write done when you are done, right? So I'm moving forward. Manam, yes, okay, Manam is also done. Okay, right. Then we come to differentiation of composite functions. Now, firstly, we are going to recall this from P1, right? In P1, we studied that if there is a function and at the top of the function, there's a power, then such type of functions are known as composite functions. Function within the brackets, and at the top of the bracket there's a power. So how do we deal with such the functions? Firstly, we deal with the power. So dealing with the power means multiply the power, and subtract the power by 1. During this process, when we are dealing with the power, the function within the bracket remains intact. It remains the same. Do not touch the function. And then at the end, the differentiation of the function within the brackets is multiplied. So if it is fx to the power of n, then n will be multiplied. Then the power n will be subtracted by 1. The function within this time will remain the same. And then the differentiation of the function will be multiplied. So n fx power n minus 1 multiplied by f prime x. So if you check out the example, which is the same as that we used to do in AS as well. If it's 2x cubed minus 3x squared to the power of 7. And we are told to differentiate this. Now how can we do that? So firstly, we are going to multiply the power. The power 7 gets multiplied. Within this time, within this process, when we are dealing with the power gets multiplied and gets subtracted by 1. So 7 becomes 6. The power 7 is multiplied. The power then becomes 6. And the function within the bracket is 2x cubed minus 3x squared, which remains the same. And then the function within the brackets, the differentiation of this will be multiplied. So 2x cubed minus 3x squared will give you 6x squared minus 6x. 6x squared minus 6x. And then if we want, if the examiner has not told us to give in a specific form, then even this particular form will be accepted. It's not essential for us to do more steps. Even this particular step will be sufficient for us. However, if we are told to give in a specific form, then we can do further processing. But what I have done over here is that I have factorized 6x squared minus 6x, and I have taken 6x as common. Then 6x multiplied by 7 gave 42x, and 42x times x minus 1 times 2x cubed minus 3x squared power 6. So this further processing steps are not required at times. Only this can be given as the final answer. Right? So this was the recall of P1. Now, using the knowledge of composite functions, let's deal with trigonometric functions. Because previously in AS, when we are dealing with composite functions within the bracket, the functions were, we were only dealing with algebraic functions. Now, all types of function can come in the brackets. It can be a trigonometric function. It can be a logarithmic function. It can be an exponential function. Anything can come, right? So if we talk about trigonometric functions, then sine power 4x. First, we need to know that sine 4x is same as sine x whole power 4. This we have been told in AS as well, that sine square x is same as sine x whole square. So keeping this thing in mind, sine power 4x is basically sine x whole power 4. So now consider this a composite function, but the difference is that now within the bracket, the function is not algebraic, rather it is a trigonometric function. So what we need to do? First, we need to deal with the power. Dealing with the power means multiplying the power and subtracting the power by 1. So we first multiply the power 4. We got 4. Then the power 4 gets subtracted by 1. We get 3. Within this time, the function within the bracket was sine x. It remains the same. Now, once we have dealt with the power, then we have to deal with the function within the brackets. The function is sine x. And we have already studied above that the differentiation of sine x is cos x. So sine x gets converted to cos x. And then at the end, we also have to differentiate the angle as we saw above as well. So then the differentiation of x will be multiplied, and that is 1. So that is why I have written PFA. P for power, F for function, A for angle. So first we deal with the power. Then whatever we get, we multiply that by the differentiation of the function. Then whatever we get, we multiply that by the differentiation of the angle. So power, function, angle. I repeat, sine power 4x is same as sine x whole power 4. So 4 will be multiplied and power will be subtracted by 1. Sine x remains sine x. The differentiation of sine x will be multiplied, and that is cos x. Then the differentiation of the angle will be multiplied, and that is 1. So 4 sine cube x multiplied by cos x, which gives you 4 cos x sine cube x. Then if you look at more examples, 4 sine cube 2x square plus 1. And we have to obtain expression for dy by dx. Now we can again rewrite this. This was a very simple example, a bit more complex as compared to the second one. So this 4 sine cube 2x square plus 1. So we can rewrite it as, although rewriting it is not essential for us. A stands for angle. P for power, I've written it over here as well. First deal with the power, then deal with the function, then deal with the angle. So it's in the note, it is written, right? So 4 sine cube 2x square plus 1. 4 sine 2x square plus 1 whole cube. First, we have rewritten it. Is this step essential for us? No. This step is not essential. We could have differentiated directly as well. So writing this is just for our own convenience, that we do not end up getting an error and we are able to differentiate properly. So if I'm writing that, then it becomes 4 sine of 2x square plus 1 whole power cube. 4 times sine of 2x square plus 1 whole power cube. Then what will happen? First, we multiply the power, deal with the power. This means multiply the power and subtract it by 1. So 3 times 4 is 12. The power 3 becomes 2. The function within the bracket remains the same. So we have dealt with the power. Then dealing with the function. So sine angle gets converted to cos angle. Then dealing with the angle, the differentiation of angle is 4x and that will be multiplied. That will be multiplied. So even if we have left our answer over here only, not writing the next step, then also it's perfectly fine, unless the examiner has asked us to convert into a specific form. So what I've done over here is 4x is multiplied by 12 and I've given 48x. Then 2 is basically, 2 will be applied over here. So sine 2x square plus 1 whole square is same as sine square 2x square plus 1. And this is cos 2x square plus 1. So we have dealt with the power. We have dealt with the function. We have dealt with the angle. Power, function, angle. Power, function, angle. Right? Now rewriting it in this particular way is not essential. So in the next example, I have not rewritten it in this form. I have done it directly. Minus 3 cos 4, 3x square minus 2x. So first we multiplied the power. 4 times minus 3 is minus 12. Cos power 4 becomes cos cube, 3x square minus 2x. Dealing with the power, multiply the power and subtract the power by 1. Then comes the turn of cos angle. Now ignore the power. When you're dealing with the function, then ignore the power. Because we have already dealt with the power, right? Now it's the turn of cos angle. So cos 3x square minus 2x is minus sine 3x square minus 2x. Minus sine 3x square minus 2x. And at the end, we differentiate the angle. So 3x square minus 2x gets converted to 6x minus 2. So first we deal with the power, then we deal with the function, and then we deal with the angle. Similarly, if you look at the fifth example, then 3 tan power 5, 1 minus 3x. Deal with the power first. 5 multiplied by 3 is 15. The power gets subtracted by 1. And during this time, tan 1 minus 3x remains same. Then tan of an angle gets converted to sec square angle. And then the differentiation of angle will be multiplied, and that is minus 3. So it becomes minus 3 into 15 is minus 45. 10 power 4, 1 minus 3x, sec square 1 minus 3x. So I've covered all 5 examples. The order is power, function, and angle. I think I've been able to explain it well, that how do we have to deal with composite functions, and especially when the trigonometric functions are involved. So copy these examples and let me know if it's clear to everyone, or if there's a doubt, then you can definitely ask me. Once you are done, write clear and done, and then I'll move forward. Yes, Javiria, you have not acknowledged yet. Have you done? But the rest of them have acknowledged. Should I move forward? Okay. In the fourth one, Javiria, I have not rewritten it as a composite function. I have not written it as it's like that. I have not written it like this. मैंने इस तरह से नहीं लिखा ना, इसलिए confusion हो सकती है. देखो माइक पे आओ, माइक ऑन करो.
थर्ड वाला सही है।
कौन सा वाला सही है?
थर्ड वाला सही है, मुझे फोर्थ में डाउट है।
लेकिन वही कह रहा हूँ, थर्ड एंड फोर्थ में कुछ फर्क नहीं है, सिर्फ एक फर्क है कि मैंने थर्ड के अंदर जो है साइन 2x² + 1 होल पावर 3 करके लिखा है, यह मैंने इस तरह से लिखा नहीं है. अब
अच्छा।
देखो, तो cos 3x² - 2x की पावर 4 जो है ये होल के ऊपर है. मैं इस तरह से लिखता ना तो फिर समझ में आता कि 4 पावर माइनस से मल्टीप्लाई हो रहा है, फिर 4 पावर 3 हो रही है. मैंने डायरेक्ट कर दिया. जब मुझे पता है कि ये 4 जो है होल ब्रैकेट पर ही अप्लाई हो रहा है, तो मैंने क्या किया कि मैंने 4 डायरेक्ट मल्टीप्लाई कर दिया. 4 मल्टीप्लाई -3 इज -12. पावर 4 जो है पावर 3 हो गई, और कॉस और 3x² - 2x अपनी जगह रहा. बस पावर मल्टीप्लाई हुई, पावर 1 से सब्ट्रैक्ट हुई, ये होगी पावर डीलिंग. यहाँ तक सही है.
जी सर।
अब पावर को इग्नोर करके देखो और ये नंबर को भी इग्नोर करके देखो क्या बचा. अगर ये लिखा हुआ होता तो ये इस तरह से लिखा होता ना, पावर 3 यहाँ लिखी होती.
जी।
तो मैंने इस तरह से नहीं लिखा, मैंने डायरेक्टली अगला स्टेप लिख दिया, जैसे जो यहाँ लिखता हूँ मैं डायरेक्ट कर दिया. तो अभी क्या हुआ कि अब मुझे सिर्फ कॉस एंगल को देखना है, ना नंबर को देखना होता है ना पावर को देखना होता है, अब सिर्फ कॉस फंक्शन को देखना होता है. सो कॉस एंगल क्या हो गया? माइनस साइन एंगल.
सही है सर।
और फिर एंड में एंगल क्या हो गया? एंगल की डिफरेंशिएशन क्या हो गई? 6x - 2. तो पावर, फंक्शन, एंगल. बस फर्क किया है कि मैंने थोड़ा डायरेक्ट किया है एज कम्पेयर टू सेकंड एंड थर्ड एग्जाम.
ओके सर,
सही है.
थैंक यू।
सिमिलरली फिफ्थ में भी मैंने यही किया है. देखो फिफ्थ वाले में भी यही किया है. 5 मल्टीप्लाई किया 15 हो गया, पावर 4 हो गई. फिर सिर्फ टेन एंगल को फोकस किया तो सेक स्क्वायर एंगल बन गया. फिर एंगल की डिफरेंशिएशन हो गई -3. तो डायरेक्ट किया.
जी।
सही है, क्लियर हो गया.
जी सर, प्लीज।
बाकी कॉपी भी कर लिया.
यस सर।
ओके, मूविंग फॉरवर्ड. ये मैंने आई हैव ऑलरेडी कवर्ड दिस. ऑर्डर ऑफ डीलिंग विद ट्रिग्नोमेट्रिक फंक्शंस इज एज फॉलोज. First deal with the power, then deal with the function, then deal with the angle, right? Okay. Now moving towards product rule. Now if we are to deal with a product of two functions, usually in AS, we were dealing with one function, right? Now if we are dealing with two different functions, those are being multiplied. If we are dealing with two functions which are being multiplied, then one of the functions is known as u and the other is known as v. Whenever two functions are being multiplied, the first one is named as u and the second one is named as v. And the formula is that we are going to, if we are going to differentiate it, we are going to write vu prime plus uv prime. Vu prime plus uv prime. What does this mean? That the second function v will be multiplied by the differentiation of the first function. U prime and v prime means the differentiation of u and v. So we have u, one of the functions is u, the other function is v. We differentiate u, we get u prime. We differentiate v, we get v prime. This v will be multiplied by u prime, and this u will be multiplied by v prime. So this is going to become vu prime plus uv prime. This is even written in the formula sheet in the differentiation section, but it is written differently. If we are going to differentiate the product uv, then we are going to get v into du by dx, means the differentiation of the u function, which we are saying u prime, v u prime, and then u plus u v prime, and the v prime is written as dv by dx, right? So this is written in the formula sheet. And also we have been written, the formula of quotient rule is written. If two functions are being divided, the function in the numerator is called u, the function in the denominator is called v. And the formula is vu prime minus uv prime over v square. Coming back to the explanation, this is the quotient rule. U upon v, is vu prime minus uv prime upon v square. So if we are going to look at the example for product rule, then we have been given y equals to x square e power 3x. Now this product rule and quotient rule are very much used in many questions, right? It's a very simple rule written in the formula sheet as well. We just need to know how to apply that. So if it's x squared times e power 3x, then the first function can be u, which is x squared. And the second function, e power 3x, can be v. Then if we differentiate u, we get u prime. So differentiation of x squared is 2x. And if we differentiate v, we get v prime. So the differentiation of e power 3x is e power 3x multiplied by 3, which gives us 3e power 3x. So x squared becomes 2x, e power 3x becomes 3e power 3x. Right? Then we need to find the differentiation. So we are going to multiply v by u prime, and then we multiply u by v prime. So e power 3x multiplied by 2x will give us 2x e power 3x. V multiplied by u prime. E power 3x into 2x is 2x e power 3x. Then if we multiply u by v prime, then 3e power 3x multiplied by x square will give us 3x square e power 3x. 3e power 3x will be multiplied by x square, and we will get 3x square e power 3x. So this is how we have got dy by dx. This was the perfect answer. However, if we are told to give the answer in a particular form, or we are told to factorize it, which is not usually the case, but just in case, if there's particular form of the answer is written, then this means we can take x and e power 3x as common. We are going to be left with 2 over here, and over here we are going to be left with 3 and x. So x e power 3x bracket 2 plus 3x. Right? So this is the application of product rule. Are we clear with the product rule? And also clear with this example? What's the name of the dash? U dash is u prime. People call it dash as well, but in sets, if you have studied, it's called prime. U prime, u dash. Okay, then if you check out the application of quotient rule, then if two functions are being divided, the function in the numerator is u, the function in the denominator is v. We differentiate u, we get u prime. We differentiate v, we get v prime. And the formula is vu prime minus uv prime upon v square. The thing to note is, in the product rule, we had vu prime plus uv prime. Even if someone changes the order, if someone writes uv prime plus vu prime, that is not going to create much difference. The answer will still remain the same. Why? Because both of them have a positive sign. But if we talk about the quotient rule, then it's very essential that we take vu prime first. Why? Because vu prime is with a positive sign and uv prime is with a negative sign. So u upon v is basically vu prime minus uv prime upon v square. So if you check out its example, also I've written one more thing before I forget. Let me tell it to you. Now we have moved on to the area of calculus, differentiation and integration. So now we are going to see that whenever in differentiation integration, trigonometry is involved. In AS, we only used to deal with algebraic functions, but now we are going to deal with trigonometric functions as well. So if we are dealing with differentiation and integration questions, that is why I always say that logs and trigonometry are the foundations. If someone is good in trigonometry, if someone is good in logs as well, then in a lot of differentiation and integration questions, trigonometry is going to be used, as we are going to see later as well. So whenever we are dealing with trigonometric functions, and if the domain is not specified, then in that case, we are going to keep our calculators in radian mode. We are going to work in radians, right? This is a point that we need to remember. So if we check out the quotient rule, differentiation of u upon v. So vu prime minus uv prime upon v square. The function in the numerator is known as u. The function in the denominator is known as v. So I've written that u is equals to x squared plus 3x. And we differentiate u, we get u prime, which is 2x plus 3. The function in the denominator is sin x. And if we differentiate v, we get cos x. Now v, this is very important. I've written 1 and 2. This v will be multiplied by u prime. This is the first thing that we need to take, because over here there is no compromise on order. V into u prime minus the second one is u into v prime. So sin x into 2x plus 3 gives 2x plus 3 times sin x. I've kept 2x plus 3 within the brackets. And then cos x multiplied by x squared plus 3x. And in the denominator, we get v squared. So v was sin x. So squaring sin x will give us sin square x. So v u prime minus u v prime upon v squared. Vu prime minus uv prime upon v square. Now, we don't have to process it any further. We cannot process it any further. And this, therefore, will become our final answer. So I've applied the product and quotient rule with one examples as well. We are going to see more such questions in past papers. And then, inshallah, we are going to master this skill of applying quotient rule and product rule. So copy this down and write clear and done so that I can move forward. Okay, moving forward. Okay. Now, these are 3 examples that we can solve. The first one is y equals to sec x. So first we need to know in trigonometry, y divide with sine square x. This is the formula, carrier, divided by v square. Vu prime minus uv prime upon v square. So v is sine x. So squaring sine x will become sine square x. So sine x whole square is sine square x. V square. Okay, clear? Great. Okay, so we were saying y equals to sec x, right? So we are told to differentiate. Now, the differentiations that we need to remember were that of exponential, logarithmic, sine, cos, and tan. Although the differentiations of sec x and cosec and cot are not to be remembered, and it's also written in the formula sheet. Sec x is differentiated sec x tan x. Cosec is minus cosec x cot x. Cot x is minus cosec square x. And then later on, we are going to look at tan inverse x as well when we are going to cover implicit differentiation, because this is derived using that only. So over here, you know what? In certain questions, we are told to differentiate sec x, but the examiner says by first writing sec x as 1 upon cos x, differentiate and show that dy by dx is sec x tan x. At times, we are going to look at such situations. So to deal with such kinds of questions, I have written it over here. There are 2 types of methods that we can look. One by one, we are going to check it out. Sec x we know is 1 upon cos x. So there are 2 methods. As per method number 1, 1 upon cos x can be dealt using quotient rule. How? 1 can be considered u and cos x can be considered v. So if u is equals to 1, then u prime is going to be 0. U is going to be 1 and u prime is going to be 0. Then the denominator, which is cos x, is v. and the v prime is minus sine x. U is 1. So the differentiation of u prime will be 0. The denominator, which is v, is cos x. And the differentiation of cos x is negative sine x. So sec x, first we write sec x as 1 upon cos x. Then 1 is the u and cos x is the v. So u is 1, v is cos x. 1 differentiated gives us 0. So u prime is 0. Cos x differentiated gives us negative sine x. Right? And then we apply the quotient rule, v multiplied by u prime minus u multiplied by v prime upon v square, the square of cos x. So if we multiply v by u prime, so cos x multiplied by 0. Then if we multiply u by v prime, then 1 multiplied by negative sine x. And in the middle comes minus because of the formula, vu prime minus uv prime. So cos x into 0 will give us 0. Minus 1 into minus sine x will give us positive sine x. In the denominator, we are going to take cos x whole square. So it's cos square x. So sine x upon cos x multiplied by 1 upon cos x. Sine x upon cos x multiplied by 1 upon cos x. Then sine upon cos is tan, and 1 upon cos is sec. So when we are told to rewrite sec x as 1 upon cos x and show that dy by dx is sec x tan x, so this is how we can show. This is one of the methods. Sec x is 1 over cos x. We dealt using quotient rule. So this is method number 1. Using quotient rule. There is method number 2 as well. Method number 2 is, this is 1 upon cos x. We can shift cos x to the numerator. So cos x whole power, it becomes cos x whole power minus 1. Now the thing to note is that sin x whole square becomes sin square x. But cos x whole power minus 1 cannot be written as cos inverse x. Because if we say cos x whole power minus 1 is same as cos power minus 1x, people will misunderstand. Why? Because inverse trigonometric function is already there present in the calculator as well. Inverse trigonometric function is a separate function, right? So by minus 1 is same as cos inverse x. So this is not the right thing. This is not the right thing. Cos x power minus 1 cos inverse x नहीं होता. Sin x whole square sin square x होता है. But cos x power minus 1 cos inverse x के बराबर नहीं होता. इसलिए इसको इस तरह से नहीं लिखेंगे, ये बात याद रखना. So if y equals to cos x whole power minus 1, then first we have, if we are differentiating, then first we deal with the power. This means we multiply the power. Now this is to be dealt using composite function rule. Over here we use the quotient rule. Method 1 uses the quotient rule. And method 2 uses the concept of composite functions. Right? Composite functions. So what happens? 1 upon cos x gets converted to cos x whole power minus 1. Then first we multiply the power. Then the power gets subtracted by 1. Then the function within the bracket, the differentiation of that will be multiplied. So the same rule, power, function, angle. So power multiplied, it's minus 1. Power gets subtracted by minus 1, so it becomes minus 2. The differentiation of cos x is negative sin x. And then at the end, the differentiation of angle x is 1. So minus 1 cos x power minus 2 into minus sin x into 1, which we have not written definitely because it was not essential for us to write that. Even if we write that, there is not an issue. Then at the end, we see minus and minus. This minus minus becomes plus. This cos x whole power minus 2 goes to the denominator to become cos square x. The sin x remains in the numerator. This minus minus gets plus. Sin x upon cos x whole square is sin x upon cos square x. Then we see that sin x upon cos square x can be written in the same way as this. Sin x upon cos x into 1 upon cos x, which ultimately gets converted to sec x tan x. So this, the differentiation of sec x is written in the formula sheet. We do not have to remember this, right? MF19. But at times we have to show how this came. So we need to show the working. So either we can use the quotient rule or we can use the concept of composite functions. Both are possible. Right? So is everyone clear with example number 1? Just let me know. Okay, if we do, follow example number 2, then that can be done in the same way. Yes, noting it down. Okay, perfect. Cosec x is 1 over sin x. And we can deal in the same way. We can either use the quotient rule or we can use the composite function. Over here, I've done the quotient rule. Sorry, I've done it using the composite functions. So 1 over sin x is sin x whole power minus 1. Then if we differentiate, then power gets multiplied, minus 1 sin x whole power minus 2. The differentiation of sin x is cos x. And then the differentiation of angle x is 1. So this becomes minus cos x upon sin square x. Then if we split, minus cos x upon sin x into 1 upon sin x. Cos upon sin is cot. 1 upon sin is cosec. So it becomes negative cosec x cot x. The differentiation of cosec x is negative cosec x cot x. Then we should know the differentiation of cot x as well. Cot x is cos over sin. Or we can also write cot as 1 over 10. If we write it as 1 over 10x, then it becomes 10x whole power minus 1. And then this can be dealt using composite functions. Minus 1 into 10x whole power minus 2 multiplied by differentiation of 10x, which is sec square x. Then sec square x gets converted to 1 upon cos square x. And then tan x can be converted to sin square, because if it's minus 2, after subtracting, then tan becomes sin over cos, and then it gets simplified to cosec square x. This is one of the methods. But over here, I've used the quotient rule, cos over sin. So u is cos x and the v is sin x. Then if we apply the quotient rule, then it's v u prime. V is sin x. U prime is the differentiation of cos x, which is minus sin x, minus u v prime. So u is cos x. The differentiation of sin x is cos x. So v u prime minus u v prime upon v square. And the v is sin x. The differentiation of sin x is sin square x. V u prime minus u v prime upon v square. Then at the end, we get minus sin square x minus cos square x. And if we take minus as common, then it becomes sin square x plus cos square x. And in the denominator, we see sin square x. Then sin square x plus cos square x is identical to 1, as we know, as we have studied in trigonometry in AS as well. And in the denominator, we have sin square x. So it's negative 1 over sin square x. 1 over sin is cosec. 1 over sin square is cosec square, and negative means negative cosec square x. Then we already know that the differentiation of tan x is sec square x. And this is, we have already remembered this. And we do not have to derive it. We can directly use this. The differentiation of tan x is sec square x. But even if we are going to derive it, how is it derived? Tan x is sin x over cos x. If we consider it to be u upon v, then it's derived using quotient rule. U is sin x, v is cos x. So v u prime cos x, and the differentiation of sin x is cos x. Cos v u prime, v is cos x, and u prime, the differentiation of sin x is also cos x. then minus u v prime. Then u is sin x, and the differentiation of cos x is minus sin x upon v square. The cos x whole squared gives us cos square x. So cos x into cos x minus sin x into minus sin x divided by cos square x. It becomes cos square x plus sin square x divided by cos square x. Cos square plus sin square will give us 1. In the denominator, we have cos square. So 1 over cos square gets converted to sec square, because 1 over cos is sec, so 1 over cos square is sec square x. I think I've done all the examples. And these were just for extra practice. They were not that essential. But at times, if you see a particular question in past papers, you are in a position to do this, right? So copy all these down and let me know once you are done. Acknowledge it by writing clear and done.
Sir,
तो वैसे हम 10x को sec square x नहीं लिख सकते। क्यों नहीं लिख सकते हैं बेटा? लिख सकते हैं। तुमने ऊपर याद भी करवाया ना, ये 10x की डिफरेंशिएशन sec square x होती है, ये आप लिख सकते हो, कोई मसला नहीं। 10x की डिफरेंशिएशन sec square x होती है, ये आप लिख सकते हो, इसमें कोई भी मसला नहीं। सही, ये मैं सिर्फ बता रहा हूँ कि ये डिराइव कैसे हुआ। ये डिराइव करने की जरूरत नहीं पड़ती। जब आपको 10x को डिफरेंशिएट करना होगा, आप डायरेक्ट sec square x लिखोगे। ये तो खाली बताने को है कि भाई 10x से sec square x आया कैसे, डिफरेंशिएट हो। यहाँ तो cot x की भी दी हुई है ना, cot x भी दिया हुआ माइनस कोसेक स्क्वायर एक्स, कोसेक भी दिया हुआ माइनस कोसेक एक्स कॉट एक्स, सेक एक्स भी दिया हुआ है तो और tan को दिया हुआ है सेक स्क्वायर, साइन भी दिया हुआ है कॉस, कॉस भी दिया हुआ है माइनस साइन। अच्छा कमाल देखें, x पावर n भी दिया हुआ है, ln x इज 1 ओवर x, ex इज ex, बस fx की फॉर्म में नहीं है, जो मैंने जिस फॉर्म में बताया था आपको। या अगर पावर होगी तो पावर की डिफरेंशिएशन मल्टीप्लाई भी करनी होगी, या एंगल होगा तो एंगल की डिफरेंशिएशन मल्टीप्लाई भी करनी होगी। But sin is cos, cos is negative sin, tan is sec square, sec is sec x tan x, cosec is minus cosec x cot x, cot x is minus cosec square x. Yes, in additional mathematics, these are not given, but over here in A levels, it's given, right? And another thing that I was saying, basically we were applying the quotient and product rule. Baki to all the differentiations are given. Sec, cosec, cot. Sec, cosec, cot, and tan. All are given. We have just derived it using product rule, or sorry, using quotient rule or using the composite function. It was just basically for extra practice. ये थोड़ा सा extra practice हो गई हमारी quotient rule की और composite functions की। बाकी इसमें कोई खास चीज नहीं। All right, then moving towards, yes. Want to ask something, Javeria?
Yes, sir. So question 3 में when we got sin
हाँ
square
बताओ।
cos square
हम्म।
divided by sin, उसको आगे क्यों simplify किया? Is it necessary?
एक मिनट, फिर कौन से स्टेप में सिंप्लीफाई क्यों किया, फिर बताओ।
Sir, question 3 में
हम्म।
the step before -1 divides sin square x.
सही है। अच्छा यहाँ तक छोड़ क्यों नहीं दिया, ये कह रही हो?
नो सर, उसको फर्दर सिंप्लीफाई क्यों किया? मतलब उतना इनफ नहीं होता?
मतलब यहाँ तक एनफ होता है, ये कह रही हूँ?
नहीं, उसके बाद वाला जो स्टेप है।
हाँ, देखो इतना इनफ तो होता है, लेकिन अगर मुझे खाली इतना बोलेगा ना डिफरेंशिएट कॉटेक्स, असल में डिफरेंशिएशन ऑफ कॉटेक्स तो दी हुई है ना, मैं तो अभी खाली ये बता रहा हूँ ये आई कैसे। तो बताने का मकसद ये है कि कॉटेक्स की डिफरेंशिएशन कभी आपको बोलेगा बाय राइटिंग कॉटेक्स एज cos x ओवर sin x, शो दैट
अच्छा।
if y is cot x dy by dx is negative cosec square, so if you have to show, how can we show? तो अभी मेरा असल पर्पस था अल्टीमेट कंक्लूजन तक पहुंचाना, एंड एंड दिखाना कि यहाँ तक कैसे पहुंचना है। सही है। तो यूजुअली जब कॉटेक्स है तो फिर मुझे यहाँ तक लाकर दिखाना पड़ता है, तो इसलिए आई हैव शोन द एंटायर प्रोसेस। In the questions, everything is going to be very, very crystal clear. You're not going to get difficulties, inshallah. The examiner is very clear with the very, very clear with the guidance given. The guidance is very clearly given in the exam questions. Okay.
यस।
Okay. Acha, determining nature of stationary points. This is another aspect. Now over here, I've written two methods of finding the nature of the nature of stationary points. So first, let's recall the method number 1 that we studied in P1 as well. Method 1 using second derivative. What was the process whenever we used to find the stationary points? Because whichever topic we are studying in A2, the prerequisite knowledge of AS is mandatory, right? So if we are, let's suppose, dealing with differentiation, then all the entire knowledge of AS differentiation that we studied in P1 is very, very essential. So firstly, whenever we have to find the stationary points, so we know that stationary points, at the stationary point, the tangent, if we draw a tangent, and it is a horizontal line, and therefore the gradient is 0. So whenever we have to find the coordinates of a stationary point or turning point, we find the gradient function dy by dx and we equate it to 0. We will find dy by dx and we will equate it to 0. So if we equate dy by dx to 0, we'll get the x coordinate, and this x coordinate will be substituted in the equation of the curve and we'll get the y coordinate. I repeat, if we are dealing with if we have to find the stationary point, turning point, we equate the dy by dx, the gradient function, to 0. Then from here, we'll get x. And if we are going to substitute x in the equation of the curve, we are going to get y. So coordinates of turning point is very simple. But for finding the nature of the turning point, as to whether the turning point is a minimum point or a maximum point, we used to use the second derivative method in AS. And that method told us that first find the second derivative. What does this mean? We differentiate with respect to x, dy by dx. Dy by dx to be differentiated with respect to x. So d upon dx of dy by dx. So d into dy will give us d square y. And dx is d square x square, but we write it like dx. Basically, this is dx whole square, but this is the method of writing. Differentiate with respect to x, dy by dx will give us d square y by dx square. So first find the second derivative, d square y by dx square. Then this x coordinate of turning point, this was substituted in the second derivative. So the second step, substitute the x coordinate of turning point in the second derivative. If the second derivative is a positive, if the second derivative is positive, then the given point is a minimum point. If the second derivative is negative, then the given point is a maximum point. Right? So first find the second derivative, then substitute the x coordinate of the turning point in the second derivative. If the second derivative is positive, then the given point is a minimum point. If the second derivative is negative, then the given point is a maximum point. This was the method that we used to follow in AS. Now, why are we not going to use although we can use this method as well in AS, in A2, sorry, in P3, but why am I teaching another method? You know why? Because this method now becomes more difficult to deal with. Why? Because if we have used product rule or quotient rule to find the second derivative, then if we have already used product rule and quotient rule to find the first derivative, then the equation that we have got has become so complex that differentiating it once again is a big problem for us. It's not that easy to differentiate it again. And normally when we see that the examiner has asked us to find the nature of the turning point, then the marks are just 2. For 2 marks, differentiating again to find the second derivative is very, very time consuming. So it's better that we don't find the second derivative. And if you're not finding the second derivative, then what we can do? We can find the nature using the first derivative only. This means that we used to find the turning point coordinates using the first derivative by equating it to 0. Now we are going to determine the nature as well using the first derivative. First derivative means dy by dx. Now, how can we do that? This is what we need to learn. So method number 2, using the first derivative. In the marking scheme, usually it says test derivative either side. In the marking scheme, it says test derivative either side. What does this mean? That we have to test, the statement usually tells us that we have to test either of the sides, either before the turning point or after the turning point. But I've seen in the marking schemes where we have to test both the sides. So we have to be very safe. I'll teach you to test both the sides. Do not take any kind of risk. We have to test both the sides. Now, how can we test? Now, this is what we need to understand. The second method tells us that no need to find the second derivative. The nature you can determine using the first derivative. How can we do that? The second method tells us that whatever the x coordinate of turning point is, decrease it slightly and increase it slightly. After decreasing it, put in the first derivative. After increasing it, put in the first derivative. So what will happen? So increase and decrease the x coordinate of turning point slightly and substitute in the first derivative / gradient function. What does the word slightly mean? There is subjectivity in this word slightly. How much do we have to increase or decrease? Let's suppose if there are 2 turning points. One is at 2 and one is at 5. So if we have to determine the nature of 2, then we have to increase slightly in such a way that we stay between 2 and 5. So if we increase, it's better that we get at 2.5. We can write 3 as well and substitute in the first derivative. If we decrease 2 slightly, then we can get 1.5 or we can get 1. But before 2, because there is no another turning point, so even if we take a much lower value, then that will also work. But after 2, because there is a turning point already there, so we have to stay within the limits 2 and 5, so that the nature of this turning point, which has the x coordinate 2, is determined. So slightly would rather mean you increase it by 0.5 and decrease it by 0.5, which usually works. But let's suppose if one of the turning point is at 2 and another is at 2.5, then increasing slightly would mean do not increase and make it 2.5, but rather substitute 2.2 or 2.3 or 2.4, but do not make it 2.5. Just for an example, usually there's a distance between the first turning point and the second turning point. So the bottom line is we have to decrease it, the x coordinate of turning point slightly, and we have to increase it as well slightly. After decreasing, we substitute. After increasing, we substitute, and then we realize if we decrease slightly and if we get the negative gradient, if we decrease slightly and if we put in the first derivative dy by dx, and then the gradient is negative. Now just look at the concept. If you remember the concept of decreasing and increasing function, at the turning point, the gradient is 0, right? But if before the turning point, the gradient was negative, this means it was a decreasing function. And after the turning point, increasing the x coordinate slightly gives us the positive gradient. This means it's an increasing function. So from negative gradient to positive gradient, from negative gradient to positive gradient, from negative gradient to positive gradient means it's a decreasing function and then an increasing function. So this only happens when the turning point is a minimum point. So if the gradient changes sign from negative to positive, and this means before the turning point, it was a decreasing function, and after the turning point, it is an increasing function. So decreasing function and then an increasing function means the turning point is minimum. So this is what is written. Let's suppose if the turning point, if the x coordinate of turning point was 1, if we decrease it slightly, we get 0.5. If we increase slightly, we get 1.5. In substituting 0.5 in the gradient function gives us negative gradient, which means decreasing function for x less than 1. Before the turning point is a decreasing function. Then if we substitute 1.5, it's an increasing function for x is greater than 1. So decreasing function first and then increasing function. Decreasing function and then increasing function. Right? First decreasing function and then increasing function. The gradient changes sign from negative to positive. So this means the turning point is a minimum point. As the gradient dy by dx changes sign from negative to positive, the turning point is a minimum point. As the gradient changes sign from negative to positive, the turning point is a minimum point. First, tell me, are we clear with this method number 2? And if, let's suppose, before the turning point, the gradient was positive. So previously it was a increasing function, and after the turning point, it's the gradient negative. This means it's a decreasing function. So from increasing to decreasing, this means the turning point is a maximum point. Just check it out over here. X 0.5, the gradient was positive. X 1.5, the gradient was negative. So it's from increasing function to decreasing function. This means the turning point is a maximum point. So as the gradient dy by dx changes sign from positive to negative, the turning point is a maximum point. Right? So are we clear with the method number 1? And both these are not solved examples. These are basically just examples to clear the concept. That if the gradient changes from negative to positive, then decreasing to increasing is a minimum point. And if changes from positive to negative, then increasing to decreasing is a maximum point. Are we clear with this? Okay, great. And if you look at this example, this is from AS, but I have solved it normally, and then I have determined the nature using both the methods to check if the answers match. So if the curve is this normal algebraic function, first, if we have to find the x coordinates of the stationary points and determine their nature, then first we find the first derivative. If we differentiate y, we get dy by dx. This is 6x squared minus 18x. So 6x squared minus 18x is equals to 0. If we take 6x as common, then 6x multiplied by x minus 3 equals to 0. Either 6x equals 0 or x minus 3 equals 0. X equals to 0 and x equals to 3. We have got two answers from here. X equals to 0 and x equals to 3. Now we only had to find the x coordinates. If we were to find the y coordinates, we would have substituted x equals to 0 first, and then we would have substituted x equals to 3 as well. But we are not required to find the y coordinates. Therefore, we have just found the x coordinates. To find the x coordinates of the stationary points and determine their nature. So for determining the nature, we first need to find, because this is just an algebraic equation. So over here, we can use both the methods. Even finding the second derivative is not an issue for us. We can easily find the second derivative. So let's suppose if we find the second derivative, that is 12x minus 18. Then if we substitute x0, the second derivative is negative. This means it's a maximum point. If we substitute 3, second derivative is positive, it's a minimum point. But let's suppose if we are not following method number 1 and if we are following method number 2, so then what we are going to do, we are not going to substitute x equals to 0 directly, definitely, because we are going to get gradient of 0 then. We are going to decrease it slightly. So decreasing 0 slightly gives us negative 0.5, increasing slightly gives us 0.5. If we substitute negative 0.5 in the first derivative, and we don't only have to write greater than 0, rather we also have to give the value so that the examiner knows that we have actually worked, right? So if we write 6x squared minus 18 times minus 0.5, 6 into minus 0.5 square minus 18 into minus 0.5. The gradient is 10.5. Now this is positive. And if we substitute 0.5, then it's negative 7.5. Which is less than 0. So if the gradient is positive and then it becomes negative, from positive gradient to negative gradient, this means from increasing function to decreasing function. From positive gradient to negative gradient, then this means from increasing function to decreasing function. This means it is a maximum point. We can draw a rough sketch as well for our own convenience, and even the examiner can look at it. First increasing and then decreasing, it's a maximum point. And if we talk about x equals to 3, then if we substitute x equals to 2.5, and we can give the value as well. So 6 times 2.5, 6x square minus 18x. And if we give 2.5, then it's minus 7.5. dy by dx is minus 7.5, which is less than 0. It's always essential to write the values. I've seen somewhere that if values are not calculated, we don't get the marks, right? So I've written it over here. And if we substitute 3.5, we get dy by dx is 10.5, which is dy by dx is equals to 10.5. And this is definitely greater than 0. I'm writing it over here. This is greater than 0. If this is greater than 0, then this means previously the function was a decreasing function and then it became increasing function. So from decreasing to increasing, the point is a minimum point. From increasing to decreasing, it's a maximum point. And from decreasing to increasing, it's a minimum point. So I've covered this example and taught you how to find the nature using first derivative as well. Note it down and then let me know if you're clear with this. Right. So we are clear. So we can solve first few possible questions as well, right? That we are able to apply. Just look at it for some time. A curve has equation y equals to e power minus 3x times tan x. Find the x coordinates of the stationary points on the curve in the interval minus pi by 2 to pi by 2. Now this interval is very essential. Always remember that whenever we are given a domain, and this domain is from minus pi by 2 to pi by 2, this means minus pi by 2 tells us that we have to rotate clockwise. And this is the fourth quadrant only. Clockwise starts from the fourth quadrant. So this means we only have to focus on the fourth quadrant. And if we talk about pi by 2, then it's anti-clockwise and it's in the first quadrant. Negative pi by 2, it's clockwise, it's in the fourth quadrant. And positive pi by 2, it's anti-clockwise, it's in the first quadrant. So a curve has equation y equals to e power minus 3x times tan x. Find the x coordinates of the stationary points on the curve in the interval minus pi by 2 to pi by 2. Give your answers correct to 3 decimal places. So what we need to do? Firstly, we are going to differentiate it. How can we differentiate it? Which rule do we have to use? We are given two functions, right? E power minus 3x into tan x. So it's a product of two functions. So which rule are we going to use? We are going to use the product rule. Okay. So this is what I've written over here as well. This domain means that using because of minus pi by 2, it's clockwise in the fourth quadrant. And using pi by 2, it's anti-clockwise in the first quadrant. A curve has equation y equals to e power minus 3x into tan x. Find the x coordinates of the stationary points on the curve in the interval minus pi by 2 to pi by 2. Give your answers correct to 3 decimal places. Now, when the accuracy is not specified, then whether it is non-angles or whether it is angle in radians, we have to give answers in 3 significant figures. If it is angle in degrees, then we have to give answer correct to 1 decimal place. Unless otherwise stated, this means if there's a certain instruction given by the examiner, that we need to follow that. So over here, the first thing that we need to identify is we have to find the x coordinates of stationary points. So we see that y is a product of 2 functions. One is an exponential function and the another one is a trigonometric function. So if e power minus 3x is considered to be u and 10x is considered to be v, then what we are going to use? We are going to use vu prime plus uv prime. I can write u and v separately or I can directly apply as well. I'm not sure why have I written this. Okay, I've written this because if someone, let's suppose if someone writes e power minus 3x in the denominator, shifts the e power minus 3x to the denominator, then it will become 10x upon e power 3x. Someone if uses this, then they can use the quotient rule. We have used the product rule, but if someone takes e power minus 3x to the denominator, then they can use the quotient rule. However, it's always better that whichever form the equation of in whichever form the quotient is given, we need to follow that, so that at times if we are not following that, then the complications increases at times. However, I've not tried it using this, so you can try if you want. So if it's vu prime plus uv prime, then v is 10x and u prime. What is the differentiation of e power minus 3x? The differentiation of exponential is copy the differentiation as it is, and the differentiation of the power will be multiplied. So v 10x into u prime. So e power minus 3x into minus 3, v u prime. Then plus u v prime. Then u is e power minus 3x, and the differentiation of 10x is sec square x. v u prime plus u v prime. Okay, then because we have to find the stationary points, then we have to equate the gradient to 0. So dy by dx is equals to 0. So now we see that this is a gradient function. What we can do to simplify it and how can we equate it to 0? So for the first thing is that always note that whenever there's exponential involved, at both the places we take it as common. So e power minus 3x taken as common gives minus 3 tan x plus sec square x equals to 0. Now we know that if the product of two factors is 0, yes, I have not uploaded the past papers yet because this is the first class of differentiation, right? So once I've covered this, inshallah, I'll be uploading the past papers as well. And then you people can attempt the past papers before the next class, and then we solve the queries as well. So if I talk about this very first question, let's focus on this first question for today only. So if it's e power minus 3x, if we take e power minus 3x as common, then we are going to get minus 3 tan x plus sec square x. E power minus 3x taken as common, then minus 3 tan x plus sec square x equals to 0. Then if the product of two functions is equals to 0, then either the first function is 0 or the second function is 0. So e power minus 3x is equals to 0, and minus 3 tan x plus sec square x is equals to 0. Then e power minus 3x is equals to 0 gets rejected. You know why? Because exponential base. E means positive base. It is 2.718 something. So if the base is positive, no matter what the power is, whether it is positive or whether it's negative, the answer will always be positive. You can try it out. Exponential to the power of minus 10, exponential to the power of minus 100, you'll always get answer greater than 0. However, if the calculator thinks that the value has become very much small, it becomes negligible, we can ignore it, and the calculator at that time will give 0. Let's suppose if you are going to try e power minus 100, then we'll get a value. But if you write e power minus 1000, then the value is 0. The value has become so small that the calculator is telling us it's a 0. However, it's not possible. Actually, the value was not 0. It was always positive. But because the value has become so small that the calculator is saying that I cannot make it further small, and that is why I am showing a 0. Always remember this as a rule, that e to the power of fx will always be positive. E power fx will always be positive. So from here, we'll not get any particular answer. Then if we talk about minus 3 tan x plus sec square x and we equate it to 0, then what will happen? Sec square x is basically 1 plus tan square x. Sec square x is 1 plus tan square x. Then minus 3 tan x plus sec square x, which is 1 plus tan square x. Tan square x plus 1 minus 3 tan x is equals to 0. Then what we can do? Now, this is a trigonometric equation and this is a quadratic equation. So if it's quadratic equation in tan x, we can assume tan x to be a, and we could have made an equation a square minus 3a plus 1. If we suppose tan x to be a, then it will become a square minus 3a plus 1 equals to 0. We can do like this as well. However, it's not essential for us to assume. We can solve directly as well. But over here, we see that factorization, that is middle term breaking, is not possible. So if factorization, that is middle term breaking, is not possible, then what happens? Then in such a case, when the middle term breaking is not possible, then in such a case, we use quadratic formula. So 10x is equals to minus b. B is negative 3. So minus b plus minus root of b square minus 4ac upon 2a. Then we have got two answers. Tan of an angle is positive 2.61803. I've worked in 5. Usually I work in 5 SF, but over here I've worked in 6 SF. So higher accuracy can always be taken, but minimum we work in 5 SF. So tan of an angle is 2.61803. Why have I have followed 5 decimal rule, because the answers are to be given in 3 decimal places. I've done the working in 5 decimal places, 2 accuracy higher than what is required by the examiner. So tan x is equals to 2.61803. Tan of an angle is positive in the first and third quadrant, but we are not going to consider the third quadrant. Why? Because whether we go in the anti-clockwise direction or whether we go in the clockwise direction, the domain is not allowing us to go in the third quadrant. So if we check out the first quadrant, the domain is telling us go in the anti-clockwise direction. And in the first quadrant, the answer is x equals alpha. So the basic angle is 1.20593, tan inverse of 2.61803. Calculator must be in radian mode. You can use the calculator to apply tan inverse of 2.61803. We got alpha. Then the answer in 3 decimal place will be 1.206. Then if the value of tan x is 0.38197, another possibility from this quadratic formula usage, then again first and third quadrant. In the first quadrant, x equals alpha, the answer is 0.365. So this is the very first question of the past papers, which is of 6 marks, and I've solved it completely. Note it down or take a screenshot of it right now. Just acknowledge if you are clear with this. Is everyone clear with this? I'll upload the past papers, inshallah, and then you can print that later on. All right, alhamdulillah. So we are done with example number 1. We have covered the explanation of the very first category. पहली category की explanation भी देख ली, एक सवाल भी देख लिया. Recording भी इंशाल्लाह upload करूंगा और past papers के सवालात भी upload करूंगा. See you all in the next class. Till then, take good care of yourself and remember me in your prayers. अपनी दुआ में मुझे बहुत खास याद रखें. अल्लाह रब्बुल इज्जत हम सबको दोनों जहानों की भरपूर कामयाबी अता फरमाए. अस्सलामु अलैकुम व रहमतुल्लाहि व बरकातुहू.